Hey, Lindsay, how are you?
Good, how are you?
I'm good.
Good. Tell me what you're working on.
So this here is integration. That's we call it taper lock machining station.
Okay.
The client asked us to retrofit a system they already had, actually 3 of them, with a new feed system. So they've got a CNC and a robot arm loading it, but it was 2 operator hands-on. So they wanted to reduce operator intervention time
Okay.
and improve their throughput. They came to us to ask us to do this, and I can show you what we come up with.
Yeah, please do.
The client is a fan of these Azuril shake tables, vibration tables. You've got different profiles. You can move the parts forward, backward, left, right. You can center them. You can flip them over. It does work to move the parts around in predetermined ways.
Okay.
And we have a machine vision system that has logic that drives these profiles. And then feeding that, we have this hopper, which we can put a full tote of parts into the hopper.
Okay.
And then an in-feed conveyor with some proximity sensors that check that there's parts on the conveyor.
Yep.
Those dump onto the table. The robot loads into the CNC, unloads the part that's done, and sticks it in the chute, which comes out this outfeed conveyor and back into the tote. This is number 2 of 3, kind of a replication of effort, but it's not as simple as just copy and paste. It had a whole unique set of challenges as far as devices talking to each other, and supposedly the hardware is the same between units, but we know that's not how that works.
Sure. I gotta get it.
Yeah, the best view might be over here. I don't know. We've been able to achieve, depending on the part, around a 4.5 second cycle time. So every 4.5 seconds, that's doing an unload, reload, dump, pick another part. 4.5 seconds on average.
Nice.
It's good work. I'm glad to be part of it.
Awesome, Ian. Thanks so much for chatting and telling me all about your project.
Absolutely.
Really cool.
Glad to talk about it.
All right. See you later.
Yeah.